So the first topic we'll be going on is a number representation. This is a topic where we deal with how to represent numbers in various bases and how to interconvert between them. So the common bases which are usually used are of these type, which are binary, octal, decimal, and hexadecimal. So in binary, you have the allowed digits are 0 and 1. You should only use these digits, and this should be used to represent all the numbers you know. And the octal similarly consists of digits from 0 to 7, and you're allowed to use only this. And the more famous decimal system, where we have the variety to use from 0 to 9, and we will represent from that. And then comes hexadecimal, which has 0 to 9 digits, and a b c d e f, these alphabets representing the numbers 10 to 15 respectively. So the concept of basis is something like this. When they give you a number like 1 to 3.45, it's given here 1 to 3.45 to the base 10. What does it actually mean is it's actually 1 times the third position from the decimal point, the radix point, to be precise. It's 10 squared, and 2 times 10 power 1, and 3 times 10 power 0. And once you cross the decimal point, it becomes inverse powers. So it's 4 into 10 power minus 1 and 5 into 10 power minus 2. This is how it works actually. So with this logic, if we can deal with all these numbers. Let's say you say 0, you say 1 1 in the base 2. It means that 2 power 1 plus 2 power 0, which is 3. So that's how we represent these numbers. So now when it comes to interconverting these digits, the point is, let's say you have a decimal number, we have a binary number which is 1010.10 in the base 2. You wish to convert it to decimal. So how would you do that? The point is like, first of all, expand it in the normal way, which would automatically give you the decimal notation, the number in the decimal notation. Like this is the first digit, left side of the 0. This is the radix point, so you put as 2 power 0 in times 0, and it's 2 power 1 times 1. It's 2 times 0, and it's 2 cube times 1. So this is the inverse power. So if you add them up, you will get the actual decimal notation, which is given in the which is obviously given in the decimal base, to the base 10. So similarly, you can convert any base you wish to decimal by the similar method of actually writing out what does actually mean. What does the representation actually mean? If you just write that down, you will automatically get the decimal representation of it. That being said, if you wish to convert the other way around, like if you wish to convert a decimal to base x, how would you do that? That is achieved by taking the number and taking that decimal number and separating it out as the integer part and separating it as a decimal part. Do this first, then take the integer part, do a long division, like divide it by whatever base you wish to do. Like suppose, let's say you wish to convert it into binary, then take divide it by 2 and note down the reminders consecutively. And if you just write them up upside down, you will get this number 1010. This is actually like, if you wish to understand the intuition behind it, it's more like, if you go to this example, it's like finding out what is this coefficient actually. Like the thing is, like, we have given this number, we wish to decompose it into these things, and we wish to find out these coefficients like 1 0 1 0 1 0. So this is the actual process of like finding reminders. So we do that to find the integer part, and to find the decimal part, these are inverses, right? Like it's 2 power minus 1, 2 power minus 2. So you just multiply it by 2 to find out the coefficient, and that is how you do it by like you just multiply it by 2, and whatever part integer part you can just write it down. So that is how you obtain this. So similarly, you can convert into any part you wish. Like suppose, let's say you wish to convert this number to the base 16, then you could do the same way. First take the integer part separately, do long division, and then deal with the fractional part by repeated multiplying to get a valid number. So that's how we interconvert between them. Suppose, let's say you wish to convert from base x to base y, then you do that by going to the decimal base. That is, first convert the base x to decimal base by the above suggested methods, then convert the decimal to back to base y. That is how you do that. So now there is actually a slight catch in these methods. The point is, when you try to convert these bases from one base to another base, you can cause representation errors. It can cause representation errors. The point is, it can sometimes lead you into an infinite loop where it's a never-ending loop. So normal digital computers won't be able to store that much memory. So that is causing a representation. It's not accurate. So to avoid that, we also have another systems of representing numbers. The method is called coding. So what you do basically is, you take a decimal number, You take for every decimal number, decimal digit, for every decimal digit, you have an equivalent coded number. That is, let's say if you use BCD system, like you have 8421. So to represent 0, you use this 0000. If you wish to represent 8, you use 1000. So with that, you can just using 2 bits, which are 0 and 1, you can represent any number you want. But obviously it is more memory taking. But the point is, you won't be having any representation errors. That's the point. And there are various coding system available, like these XS3 and BCD 1. All those things are available. So that is one thing you note down. And the last thing to deal with in this subpart is representing negative numbers. How do you do that in with only in binary? So the point is, the general idea to start with, deal with the problem is, you can add an extra bit in the front. That is, once you give the number and you can add extra bit saying it could be either 0 or it could be 1. That is one way of doing it. The point is, you take any number x and you can add 0 to the start, denoting a positive number, and then take a 2s complement of it. What does it actually mean to take a 2s complement? Is you're basically uh, trying to figure out how does one can make the number satisfy the condition a plus minus a is 0. So to that way, actually we have discovered this method, that is, first add 0 initially, then flip all the bits individually, that is, pass all the bits through a NOT gate, which I'll be explaining later. So so you'll get, if you take the 0 1 1, you will be getting 1 0 0. Now it's actually a 1s complement. So to make it as a 2s complement, you add 1 to the last bit, you'll get 1 0 1. So if you take this number 101 and if you take the previous actual number 011, if you add them up, you'll get 0. There will be some carry, but ignoring the carry, the sum will be 0 0 0. So this suggests you that whenever you take a 2s complement of a number, this behaves as a negative number of the original number. So this can be used to construct and represent negative numbers in binary system.